Hi, my name is Elias Knaser, and I'd like to welcome you to VMware vSphere 4 Training DVD. In this CBT, we're going to be covering all the new features that were released with VMware vSphere 4. Stuff like VMware Fault Tolerance, vCenter Orchestrator, Thin Provisioning, vShield Zones, vNetwork Distributed Switches and the Cisco Nexus 1000V, and much more. VMware vSphere 4 is without a doubt the most powerful virtualization platform to date. And what we hope to accomplish with this CBT is to give you the necessary knowledge and tools that allows you to properly design, install, and configure an extremely well-tuned vSphere 4 environment in your organization. We've also designed this CBT with the VMware VCP certification exam in mind to serve as a study guide or a study aid or just a refresher for those of you that intend on sitting the VCP exam. But what I also wanted to do with this course is to pour my knowledge. As a consultant, I've traveled from customer to customer, dealing with design issues, install issues, and configuration issues. What I want to try to arm you with in this CBT is the right knowledge, the best practice that I've gathered over the years that would help you avoid that 2 o'clock in the morning phone call. So without further ado, let's go ahead and get started with the introduction module. Before we talk about VMware vSphere 4 or even virtualization in general, let's try to understand why virtualization became so popular, why it infiltrated every data center in the world in one way or another. Let's take a look at the legacy data center. If you walked into any data center prior to virtualization, you will notice that it was crowded with physical servers. These physical servers had high demand for power. They needed cooling. They needed more floor space. This floor space, if it was in a co-location, was very expensive. In most cases, these physical servers were underutilized as far as CPU, as far as memory. Some studies show that it was up to 10% utilization, which is nothing compared to the amount of resources that were available to these physical servers. So what was the problem? So traditionally, or over the years, we've developed this habit of siloing applications. We would bring up a server for a single application. So you would have one Exchange server, one SQL server, one Oracle server, one file server. So every physical server served a specific function, what we call as siloing. And we've done that over the years in order to avoid issues, mainly conflicts. We didn't want to put a SQL server with an Exchange server, simply because we didn't want them to compete for resources, but also because we didn't want any kind of application compatibility issues. We didn't want an update that was released for SQL Server to affect in any way our Exchange environment, so we kept them all separate. We didn't want a single application failure to affect the other application, and we wanted the ability to take down an application without affecting another application, and thereby the habit of siloing came into place. The result, though, was underutilized servers. Now that's not the case for everything. Some servers overutilize the resources. You'll take a look at some Exchange servers, some SQL servers that need more horsepower. But in general, file servers or web servers or directory servers tend to have extremely underutilized hardware. And that's where virtualization comes into play. Virtualization, in a nutshell, is the process of separating the software from the underlying hardware that it resides on, thereby allowing us or giving us the flexibility of having multiple virtual environments that can take advantage of a single physical resource entity. And this in turn will allow us to maximize the utilization of the resources on a single server or a single computing resource. But why would you virtualize? Aside from maximizing the hardware, why would you virtualize? Well, virtualization gives you a lot of benefits. Some of the benefits can be seen in time, money, and energy. And what we mean by time is the time to spin up a server. Traditionally, you would have to buy a server. You'd have to install the software on it, you have to configure it, install the applications, configure them, etc., etc. Or use some kind of an imaging. This would typically take anywhere between 1 to 3 days depending on how busy you were or the availability of resources that you have. Well, in a virtual environment, you can spin up a virtual machine in a matter of minutes. And if you have any kind of gold images or templates, then you can spin up a fully functioning environment in a matter of minutes. But it would reduce the time for you to make certain servers and by reciprocity, certain services available to the business quicker, so therefore they can concentrate more on how to go out and make money. It would save you money because you don't have to go out and buy a physical server every time you need to bring up a server. Now you can carve up a virtual machine on existing hardware, so that would save you money. It saves you money as far as energy. So because you don't have all these physical servers anymore, you don't have 15 or 20 or 30 physical servers, you save in energy costs because now all your virtual machines are living on 1, 2, 3 or a set of hosts. So you reduce the number or the count of physical machines that you have in your environment, thereby automatically reducing your energy bill as far as power, cooling, etc., etc. But there's also hidden costs. For example, you reduce the amount of floor space you need. Your data center doesn't need to be as big as or as large as it used to be in the past because you don't have the same amount of physical servers. You have less physical servers. You don't need as much or as many people to manage your IT infrastructure because now you have less physical servers to worry about. You don't even need that many people as far as your human capital or HR is concerned because you're not hiring as much. And this is, of course, from an IT perspective. You're not hiring as much, so you're reducing that cost as well. Now, as you may or may not know, there are different types of virtualization. The most popular is operating system virtualization, otherwise known as server virtualization, which allows us to take the software, separate it from the physical hardware that it resides on, thereby allowing us to have multiple instances of a guest operating system running on the same hardware with the use of what's known as a thin hypervisor, and we'll get into that in a little more detail later on. The second type of virtualization that's available is application virtualization. What application virtualization allows you to do is to take an application and run it on an operating system without actually installing it on an operating system. Now this is very cool because it allows you to avoid application conflicts, and we're going to get into detail on application virtualization a little later on. But the way it works is you combine or you gather all the necessary DLLs or registry entries that are needed to run this application. You put them together in a set of files, and it gives you the ability to run that application on the operating system without actually having to install it. The third type of virtualization is storage virtualization. What that allows you to do is to gather storage from different parts on your network. So you can get storage from file servers or from the SAN, from different places, and present them virtualized to your hosts. So as far as the host is concerned, they're seeing one entity of storage, but they don't know where this is coming from or how it's put together. Now, one of the most common questions I'm always asked is, what is a hypervisor? A hypervisor is a thin layer of software that gets installed on bare metal that allows for the creation of multiple VMs in an isolated state. So it allows you to have more than one virtual machine running on the same hardware, yet completely isolated from one another. Think of a hypervisor as a maestro. It is a regulator that allows or that tells the VMs when and where and how to access the physical hardware. Now, without a hypervisor, if all the VMs were trying to access the hardware at the same time, it would be chaos. The server would crash almost instantly. So the hypervisor's role is to control or to timely control which virtual machines get access to which type of hardware, when, and for how long. Now today there are two types of hypervisors. There's what's known as a Type 1 hypervisor, which is a bare metal hypervisor. This is obviously the most efficient, the most performance you're going to get is out of a Type 1 hypervisor, whereby the hypervisor is installed directly on bare metal, and then you start creating or carving up your virtual machines, and it regulates access to the hardware that way. And then there's Type 2 hypervisors. What Type 2 hypervisors are like hosted hypervisors. You might know this through Microsoft's Virtual PC, for example, or for the server, it's Microsoft Servers, Virtual Server. VMware Workstation falls in that category. So let's take a look at some of the operating server virtualization that's available out there. So some of the vendors you see, Citrix Xen Server, for example, is a Type 1 bare metal operating system where the hypervisor will get installed directly onto the hardware. Microsoft's Hyper-V is the same way, and obviously VMware ESXi and vSPHERE is a Type 1 hypervisor. Now in contrast, When we take a look at the host-based hypervisors, we'll notice that VMware Server, Workstation, and Fusion fall into this category, as well as Microsoft Virtual Server 2005 and Virtual PC and Parallels. Application virtualization, on the other hand, there are several different vendors that do application virtualization. You have Microsoft's AppV, which used to be called SoftGrid, and that was an acquisition that Microsoft made in the past few years from a company known as Softricity. Really cool technology. Again, application virtualization allows you to run an application fully functional without having to install it. Just think about the possibilities of being able to offer your users, especially if you're in a litigation, for example, access to different versions of Word. Word 97, Word 2000, 2003, 2007, without having them conflict with each other, or having Word and some other application installed on, or giving them access to those applications from one operating system without having any kind of conflicts, updating them, upgrading them in a fly. Citrix XenApp falls into that category. Now, Citrix XenApp is serving up the application in a different way, but Citrix also has streaming applications. VMware also has a solution known as ThinApp. ThinApp was a VMware acquisition in the past few years that's very similar to Microsoft's AppV. And if we move on to storage virtualization again is the aggregation of different storage from different places on your network and presenting them as a logical entity to a host. There are different vendors or several vendors that can do this. Almost everyone is doing this today. DataCore, Left Hand, Hitachi, a lot of different vendors are in this space. This is very cool because it allows you to take advantage of a lot of unused space that you may have or storage that you may have on the network. Obviously here you want to take consideration the speed and the reliability of those disks, but at least you have an opportunity, or you have the ability now to take advantage of it for the right type of application. So what's a virtual machine? A virtual machine is a collection of virtual hardware that creates a standard x86 or 64 PC environment that allows an operating system to get installed. Now, what does an operating system need in order for it to install and complete the installation successfully? It needs to see certain hardware components. Now, as far as the software is concerned, it can't make the distinction if this is a hardware component or if this is a software or logical component. As long as it sees the necessary components, it's going to install. And that's what a virtual machine presents to the guest operating system. It presents it with the correct environment that has all the necessary components that the operating system needs in order to install successfully. This will include virtual CPU, a virtual hard disk, RAM, network adapter cards, SCSI adapter cards, etc., etc. Now, the cool thing about a virtual machine is that it's made up a collection of files. It's like, having a file server with different files. That's your VM, that's your server as files. Now, depending on the different type of hypervisors or the different hypervisor that you're using, you're going to have files with different file extensions. You'll have Microsoft with VHD and VHC. You'll have VMware, VMX, and VMDK. Obviously, the VHD is the virtual hard drive, and the VHC is the configuration file. Similarly, the VMX is the configuration file, and the VMDK is the actual hard drive or the virtual drive. Citrix has opted to go with the Microsoft standard, the VHD standard. Now, this is good because in time, hopefully, we'll have a standard that allows a virtual machine to cross hypervisors, to be able to run on different types of hypervisors. This is going to be especially important with the introduction of client hypervisors, where the hypervisor now can be installed on a laptop or a desktop and is not limited to a server. It'll be very important to be able to have a virtual machine cross different hypervisor types. So it can go from Microsoft Hyper-V to VMware ESX to Citrix Xen Server 222. That's going to be extremely important in the future to have a single standard for files that are related to virtual machines. But why virtual machines? What makes virtual machines so much different, so much better than a physical machine? A physical machine can be extremely difficult to copy, to move. You need third-party utilities. You need to have Ghost or Altiris in order to image them and then deploy them. And if they're not deployed on the same type of hardware, then you're going to have driver issues and compatibility issues. You can't move them easily. And physical machines, in most cases, will have underutilized resources. But how's it different with virtual machines? Well, virtual machines are just a combination is just a collection of files. So you can back them up just like you back up any of your regular files. You can restore them regardless of the underlying hardware. As long as the hardware meets the virtualization requirements, that VM is just going to come back up. It doesn't care if it's running on an Intel or on an AMD. You can move it around. You can take your virtual machine from data center A, restore it in data center B, take it from your production environment, restore it in your DR environment. It simply does not care because it doesn't have that underlying relationship. It's not tied to the physical hardware. It's hardware independent. So back to the hypervisor OS vendors. So we've chosen 3 vendors here. VMware, obviously. VMware has Workstation, Server, ESX, ESXi. Microsoft has Virtual PC, Hyper-V, Virtual Server, and Citrix has Zen Server. There's a lot of other hypervisor vendors out there. Actually, there's so much that we can't even put them all on this presentation. Phoenix is coming out with one, Oracle has one, HP's coming out with one, a lot of different vendors. But these are the 3 vendors that we think are going to have the major impact in the future on the hypervisor or in the virtualization space. And this brings us to VMware vSphere 4. vSphere is a collection of applications that make up an enterprise suite. It gives you the ability to do enterprise virtualization. It gives you all the necessary applications, all the necessary tools that allows you to deploy a virtualization for an enterprise, that allows you to take out these physical servers and gives you a solution that you can rely on. There are 2 main components in the vSphere suite. You have the ESX host, noted here as VMware ESX server, and one of its major components is VMware's Virtual SMP, and we'll talk about that a little later. And then you have VMware Virtual Center. Virtual Center, now renamed to vCenter. I just wanted to make the notation here that the V stands for virtual, obviously. And it has the following components and much, much more that we're going to get into details as we move on. VMware vMotion, Storage vMotion, Update Manager. These are some of the basic features now that were introduced over the years with 2.5 and 3.0 and 3.5, and then we're going to talk about what's new with vSphere 4. But before we do that, let's take a look at the underlying structure of ESX Server. Now keep in mind we're talking about ESX here, not ESXi. And as you'll notice, the physical and logical structure of an ESX server is comprised of the underlying layer of hardware, hard drives, memory, CPU, network, etc. And then you have the VM kernel, otherwise known as the hypervisor, which allows virtualization. It allows you to have a Windows machine and a Linux machine running on the same hardware without conflicting with one another and in complete isolation. But you'll also notice the service console. Now the service console doesn't exist with ESXi. I want to stress this, especially for those that are taking the VCP exam. The service console only exists with ESX, and with the future releases of ESX, whether it's vSphere 5 or whatever it's going to be called in the future, the stated course or VMware is telling us that eventually the service console will be phased out. Now we'll talk about the service console on a different slide, but I just wanted to show you the structure of ESX Server as it stands today. And again, the service console doesn't exist with ESXi. Virtual SMP, or Virtual Symmetric Multiprocessing. What does that mean? That is the technology that allows you to assign more than one virtual CPU to a VM, up to 8 vCPUs per VM. And that's useful for application or resource intensive applications that need more horsepower, your exchanges, your SQL servers, your Oracle servers that might need more horsepower in order for them to function and be more responsive. Virtual Symmetric Multiprocessing gives you that ability. And now we get to the Service Console. What is VMware Service Console? The Service Console is a 64-bit console operating system that interacts with ESX Server and all of the virtual machines that are running on it in order to provide services like firewall, SNMP agents, etc., etc. Now the Service Console, you can think of it as the first virtual machine that comes up once the installation of ESX Server is complete. It is compatible with a Red Hat Enterprise Linux 5.2 or CentOS 5.2 or any equivalent Linux distribution for that matter. Now it's based off of a 2.6 Linux kernel as stated here. Now all this information is very relevant, especially if you're about to take the VCP exam, so I just wanted to make that note. Now let's move on to the VM kernel. What is the VM kernel? The VM kernel is otherwise known as the hypervisor. Again, we spoke about how the hypervisor regulates access of the different virtual machines to the different physical components on that server. Now, it's very important to note, and again for the VCP exam, that the VM kernel is not a Linux distribution. That is a fatal mistake on the VCP exam. Do not make it. The VM kernel is a proprietary piece of software that VMware wrote. It has nothing to do with the Service Console operating system, which extends services like firewall and SNMP agents, etc. that we talked about. So now we get to ESXi, the structure of ESXi. ESXi is a centrally managed hypervisor that does not rely on the Service Console. It is self-sufficient. What ESXi gives us is a really thin hypervisor. And what it also does is it removes an attack surface. So some of the critiques that we had with ESX Server is that it had a Service Console. So it was more vulnerable to security or to attacks, and therefore the question always came up, do I need an antivirus for the console operating system or for the Service Console? How do I harden the Service Console? How do I prevent someone from attacking the Service Console? So what VMware did is, with the release of ESXi, they took away that Service Console. So they removed an attack surface. You don't need to put an antivirus anymore. You don't need to worry about hardening it. It no longer exists. You don't need to back it up for that matter. Again, it no longer exists. So, you take away that headache altogether. Now, I will say this, and the reason the Service Console is still around is because there's a lot of people over the years, because it's been around for so long, have developed scripts to automate things. Third-party tools and utilities and vendors have created software that ties very closely into the Service Console in order to extend some of the features. So what VMware is trying to do is trying to phase it out slowly. It's telling people the Service Console is going away. The future of ESX is going to be ESXi, an extremely thin layer hypervisor that has the Virtual Center Management Server to run all of its enterprise capabilities. Which brings us to Virtual Center Server. Now, Virtual Center Server, as it stands today, is a Windows-based application. Now, when we were recording this CBT, there was already a Linux version of the Virtual Center Server in beta. But I'm not going to talk about that. It's just going to be a different operating system. The features and functionality are going to be the same. So we're going to focus on what we have as general availability today, which is a Windows-based application designed to provide enterprise-class features and functionality to ESX Server, or to ESX and ESXi in general. Virtual Center is what allows you to do vMotion and resource optimization and high availability and fault tolerance and vShield zones. So think of vCenter as the perfect companion to ESX. ESX provides you with the hypervisor, the thin layer of hypervisor. Virtual Center brings all of the enterprise features that you need in order to run an enterprise-class virtualization infrastructure. So let's take a look at some of the components of Virtual Center. Now, all the components listed here, we're going to go into a brief description in this introduction module, and as the course progresses, we're going to dig deeper into each one of these features. Now, these are some of the traditional features that come with Virtual Center. In a different slide, I've highlighted some of the new features that are available with the release of vSphere 4. vMotion. We talk about vMotion so easily today. If for those of you that have been following these CBTs for a while, the first iteration of my CBT, which was based on ESX 3.0, I was amazed at the functionality and the features and technique behind vMotion. It's actually the single feature that drew me to virtualization. The ability to take a virtual machine that is fully functional online and move it from host A to host B without an interruption in service to the user. That was truly amazing. Today we're talking about the technology of, yeah, whatever, it's old stuff. But when it first came out, it was really amazing to be able to take a virtual machine and move it while it's online without powering it off from host A to host B. In a nutshell, it's a live migration between hosts. Storage vMotion. As if vMotion alone wasn't enough, VMware then introduced storage vMotion. So with vMotion, what you did is you moved the logical representation of a virtual machine from host A to host B, leaving the files that made up that virtual machine static on the SAN or on the local disk, wherever they were. Well, not local disk, you need shared disk. So you kept the files on shared disk. VMware took it one step further. With storage vMotion, you can now move the files that make up that virtual machine from storage A to storage B. So from one shared storage to local storage, or from one shared storage to another shared storage, thereby making storage migrations if you're in the process of moving SANs, or if you just want to elevate the performance of that virtual machine from a tier 3 to a tier 2 or tier 3 to a tier 1 type of disk. So vMotion allows you to move the virtual or the logical representation of that virtual machine from one host to another. Storage vMotion now allows you to move the files. So the combination of vMotion and storage vMotion, you can move a virtual machine while it's running, while it's online, with all of its prerequisites as in terms of files, from one host to another and from one storage location to another. Folks, this is stuff that we could only imagine doing in the physical environment. It's available to us now because we're dealing with virtual servers, because we're dealing with logical representations, with files. It gives us that flexibility. More cool stuff with Virtual Center. Distributed resource schedule. What that does, what this technology allows you to do, is it allows you to do a proper resource load balancing. So what it will do is, it will notice that VM1 is consuming a lot of CPU and memory on ESX Server A. But the problem is ESX Server A is running out of CPU and memory and resources. So what it will do is it will take that VM and migrate it, vMotion it, to an ESX host that isn't so strained on resources, that has more resources available to it, thereby doing a dynamic load balancing of resources across the hosts. Now this is awesome because it allows you to add more ESX hosts on the back end, add more horsepower, and then allow distributed resource schedule to dynamically distribute those VMs on the least busy server. And all of this without affecting the user, without bringing that VM down. All this is done online. Now speaking of availability, this brings us to another functionality, another feature called high availability. What high availability allows you to do is, let's say you had a bunch of virtual machines that are running on host A, and all of a sudden host A completely fails. It will bring up those virtual machines on host B. So because host A and host B can both see the same shared storage, they both have access to the same virtual machine files, in the event that host A should crash, host B is able to bring up those virtual machines back on the resources that it has available, and then DRS will then do another distribution of resources on the remaining hosts that are online, and thereby doing another dynamic rebalancing. So high availability is extremely cool because, again, that host fails, the VM will go offline for whatever time, 1, 2 minutes, 3 minutes, whatever it takes for it to come back online on a different host, thereby increasing the level of SLAs and your high availability time. Continuing on the path of high availability and maintenance, and VMware Consolidated Backup. Consolidated Backup is a framework that allows third-party utilities to plug in and back up virtual machines that are running in your virtual center or in your virtual infrastructure in general. And we're going to talk a little more in details and in depth about VMware Consolidated Backup when we get to that module, the backup and high availability module. This brings us to what's new in vSphere 4. vSphere 4 was a great release with tons of new features. Some of the features were awesome, such as fault tolerance. That made me as excited as I was when I first saw vMotion. And we're going to go through the whole list and talk in brief about them. And as the course progresses, we're going to dig deeper into what each one does and how it's configured and how it plays out. Fault tolerance, like I was saying, is a feature that is just extremely cool. So what we have with high availability, with VMware high availability, is if you have host A fails, host B is able to bring up the failed VMs because it has access to the same shared storage. But what the problem is there is you have loss of connectivity because you have one host that completely fails. Those VMs that are on it fail, they would have to automatically be brought up. So there's that downtime. Fault tolerance takes it one step further. So if you have virtual machines that you can absolutely not afford for them to go down, you can enable fault tolerance on them. What fault tolerance is going to do, it's an extension to high availability. It's going to create a secondary mirrored VM that lives on a separate host. That secondary mirrored VM is in lockstep with the first or the primary VM. Everything that gets executed on the primary VM gets executed on the secondary VM at the same time. What that results in is if host A, which is carrying the primary VM, goes down for whatever reason, host B, which is carrying the secondary VM, is automatically going to kick in, and it's automatically going to assume the identity and the responsibility of VM A without the loss of connectivity or service, so without any kind of interruption to the user or to the service that that virtual machine is providing. That is just simply fantastic, because at that point that virtual machine cannot go down. The only way that virtual machine would go down is if all the ESX hosts or the whole data center goes down, for that matter. Now guys, tell me that's not cool. I mean, you can have this for Exchange servers, for SQL Server, for those servers that you absolutely don't want to go down. You can enable fault tolerance, 2 virtual machines that are living in lockstep on 2 different hosts. Any kind of tasks that are executed on VMA are going to be executed on its mirrored VM at the same time. It's just fantastic. So do you guys remember hot swappable in the physical days, where they would be able to tell us, oh yeah, sure, you can open the physical machine if you want and add some more memory to it? How many of you actually did that? Maybe, I don't know. I've done it maybe once, and I didn't like the experience. With virtual machines, up until before vSphere was introduced, we couldn't do a lot of hot add. We could add a hard disk, maybe virtual hard disk. With hot add, now you can increase the memory on the fly without bringing that virtual machine down. You can increase the amount, how many CPUs or virtual CPUs that it has access to without bringing the virtual machine down. You can obviously still add hard drives or virtual hard drives while the virtual machine is powered on. Thin provisioning. What thin provisioning allows you to do is to allocate storage to VMs or to your ESX hosts without actually committing that storage. So you might be able to allocate more storage than you actually have, and as the hosts or the VMs start using that storage, you can go ahead and buy more, or bring more and commit that storage to disk or to the hosts or VMs that are being used. Now what that allows you to do is, traditionally we've always allocated more storage than we've ever used, or we've allocated storage but it's taken us so many months or so many years to use that storage that we could have used it somewhere else and saved the money. What thin provisioning allows you to do is, if someone comes up, or you want to allocate a certain number of bytes or gigabytes or terabytes, whatever the case might be, to a system, you can allocate that without actually having that. So you're telling a virtual machine, you have 500 gig, but that virtual machine is only using 50. Now that virtual machine expects to be able to use that 500 gig when it needs it. The difference is, you as an administrator have logically carved up a 500 gig LUN to that virtual machine or to that host. On the back end, from a physical standpoint, you might not have 500 gig, but you want to make sure that you have that 500 gig when that virtual machine or ESX host needs access to it. So thin provisioning allows you to allocate more disk or more storage than what you have, but it doesn't force you to commit to that storage or to that disk until the virtual machine or the ESX host needs access to it. Now thin provisioning is usually done on the array level. Whatever SAN you're using typically will offer some type of thin provisioning. What VMware is doing here is it's offering thin provisioning from the ESX or the vSphere layer to those people that are using some type of shared storage that doesn't have thin provisioning. And we're going to get into more details on thin provisioning and how to use it in different case scenarios when we tackle storage in a later module. But I just wanted to give you a brief introduction to it. More cool features with vSphere 4. VM Direct Path. In the past, the argument that some had in order to not virtualize certain servers is that, virtual machines can't handle some I/O intensive applications because of it can't handle the I/O. So what VMware did is it created VM Direct Path. What VM Direct Path allows you to do is it allows you to take a physical PCI card, whether that's an HBA or a NIC card, whatever the fact might be, or whatever the matter might be, and directly attach it into the virtual machine. Thereby that virtual machine now has direct access to that physical piece of hardware, thereby giving it all the I/O throughput that it needs. If you need more, you need an HBA that's directly attached for a SQL server or for an Exchange server, go ahead, attach that HBA card directly into that virtual machine and allow it to take advantage of all the I/O bandwidth that it needs. The same thing goes for network interface cards, etc. Now, one of the limitations that you'll have with VM Direct Path is if you've attached a PCI device into a virtual machine, then that won't allow you to vMotion that virtual machine around. Hopefully, in the future, VMware or its competitors, but VMware in this case, will find a way to allow that virtual machine to be vMotioned if it can find an available, compatible PCI device on the host that it's being vMotioned to or that it wants to be vMotioned to. But as it stands today, VM Direct Path will prevent a virtual machine from being migrated from one host to another. More and more features. You guys are seeing why this is such a big release. vNetwork Distributed Switch. Now, traditionally, what we had with versions of ESX prior to vSphere is every ESX host had its own virtual switches. So you would have to configure the virtual switches on a per host basis. What VMware did with vSphere 4 is it now has what's known as a vNetwork Distributed Switch, where you have a centralized virtual switch that every ESX host can be a member of, and instead of configuring virtual switches on individual ESX hosts, now you configure them centrally through Virtual Center on one virtual switch that works on across all ESX hosts. Pretty cool stuff. And that leads us automatically into the Cisco Nexus 1000V. The Cisco Nexus 1000V is a third-party vNetwork distributed switch. Think of it as a plugin, as an enhancement to vNetwork distributed switch that allows you to do stuff like quality of service, private VLANs, access control lists, and so on and so forth. And since it's also running Cisco NX this gives your networking team more insight into it because they're familiar with that OS from the different networking gear that they're using in the data center. So a lot of advantages for using the Cisco Nexus 1000V. If you're a Cisco shop, your network team is going to love having that in the environment. And this is just opening the door towards having more third-party vNetwork distributed switches plug in to the vSphere framework and take advantage and expand on the functionality that is available within the infrastructure. More networking talk. vShield zones. What vShield zones allows you to do is to isolate certain parts of your virtual networking environment by firewalling them off. It allows you the ability to monitor and manage the network traffic flow, thereby applying security policies to virtual networking. This is an extremely cool tool, especially for compliance reasons. If you needed to have certain aspects of the virtual network isolated for compliance reasons with vShield zones, that allows you those capabilities. This brings us to vCenter Orchestrator, which is an automation engine. What allows you to do is take workflows, certain tasks that you want to implement, and allows you to automate those tasks at a specific interval or a specific runtime. And the vSphere client, it's a Windows-based application that allows you to connect to either ESX server or the ESX host or the virtual center server in order to configure, manage, and manipulate the environment. And this brings us to the summary of this module. So to sum it up, virtualization offers significant benefits in comparison to traditional data center practices and methodologies. And with the use of VMware vSphere 4, you have access to a suite of very powerful enterprise-level applications that allows you to bring the best of both worlds into the enterprise. You can continue to silo your applications onto servers, but you now have the ability to provide high availability, fault tolerance, distributed resource schedule, vMotioning, backup in a more efficient way that automatically leads to better disaster recovery and more uptime. And to finish this off with the final item here, a complete virtual infrastructure is made up of obviously a virtualization platform, the physical network, and a storage topology. In the end, I hope this module has been informative for you, and I'd like to thank you for viewing.